Just a quick video here to review the investigation. If you haven't already done this investigation, please stop and do the investigation first, and then come back and check your work, and then we can talk about it. So we're looking at the integral from a to b and areas. So does the integral from a to b of any function always give us an area? That's the question we're talking about. So what to do? We want to find this and this. Okay, so first of all, the integral from 0 to 1 of x cubed is definite integral, so we do not need c, constant of integration. This becomes x to the power of 4 divided by 4, so 1/4 x to the power of 4. Which is 1/4. Substitute in 1. And then substitute in 0, but that second term just equals 0, and the first term just equals 1/4. Okay, secondly, the integral from -1 to 1 of x cubed dx. Same integral, so 1/4 x to the power of 4 from -1 to 1. So substitute in 1. And then substitute in -1. So this first term is 1/4. Subtract. The second term is also 1/4, so that equals 0. Okay, so number 2, explain why the first integral in 1 gives an area, whereas the second integral does not. It's 0, so there's no area. Graphical evidence is essential. Okay, so let's take a look at what this function x cubed looks like. It's like this. So if we're looking at this first integral from 0 to 1, say it's from here to here, I'll put -1 over here, then we're looking at this area. And we determined that that equals 1/4. Okay, and I should have units squared there. The second part is from -1 to 1. So from -1, we're looking at this. From -1 to 0, and then from 0 to 1, we're looking at this part. Okay, so it's no wonder that that equaled 0 when we calculated it out. Those are symmetrical, and they would lie right over top of each other and cancel each other out. So what are we finding out here? That this gave us, this part over top of the x-axis gave us positive 1/4 units. This part underneath the x-axis gave us -1/4 units squared. Okay, so interesting to note. Number 3, find same function x cubed from -1 to 0. And actually, we just did that. We just talked about that up here. It's going to be this -1/4. But let's do it. So -1 to 0. 1/4 x to the power of 4 from -1 to 0. So that would be substituting in 0 first, and then substituting in -1. That's 0. Subtract 1/4, which is -1/4. Okay. Number 4, check that. So same function, x cubed, from -1 to 0 plus from 0 to 1 is the same as from -1 to 1. So we don't need to redo this work. Let's go back and look. Here in number 3, we did this first part from -1 to 0, and we got -1/4. Okay, up above from 0, so now we're finding from 0 to 1. So let's look up above here. From 0 to 1 was this, and we determined that that is 1/4. So plus 1/4. equals from -1 to 1. I think we did that up here as well. -1 to 1, yes, and we determined that that equals 0. And we determined that equals 0. So does -1/4 plus 1/4 equal 0? Yes, it does. Check. Number 5, find from 0 to -1. Okay, so from 0 to -1. Now, usually when we're looking from A to B, this number is smaller than this number. But in this case, B is smaller than A. Okay, so integral from 0 to -1, x cubed dx. Which is substitute in -1 and then substitute in 0. That equals positive 1/4 subtract 0, positive 1/4. Okay, so notice that if this would be looking at from 0 to -1, this would be looking at this part of this function from 0 to -1. So going back in the opposite direction, we ended up with a positive number, positive 1/4. It was underneath the x-axis. Was this part underneath the x-axis, and we went from 0 to -1. We got a positive number, which could be the area. Number 6, suppose the function is a function such that all of that function is below 0. In other words, the whole function is below the x-axis. Everything occurs below the x-axis. For everywhere on the interval we're looking at, A to B, can you suggest an expression for the area between the curve and the function? And that expression then should be negative the integral from A to B of the function, integral of the function. Or we could say the integral from B to A. So both of those would be true. Okay, thank you. Hopefully you put some of your own thought into that and came up with those solutions. That's it.